Hi guys, it's Miss Jackson again. This is video number 2 going through two-step mole conversions. You'll need your note guide out for this, just like for the first one. This video, however, these 5 examples will go on the front side. Okay. We're going to look at two-step problems. We're going to look at how do I know it is a two-step problem like this week and not a single-step problem like weeks 2, 3, and 4. So have your calculator out, have your note page out, and have something to write with. All right, so, well, goodness sakes. All right, we're still looking at the same triangle that we looked at before, okay? The mole is the central unit, so if I want to convert from mass to atoms, okay, or atoms to mass, I have to go through the mole. There is no direct line from an atom particle to the mass. The only way to get there is to go to the mole and then back out of the mole. So we're going to look at how do we know that it's a two-step problem, and it's really simple. And you have to ask yourself, all right, if the problem either gives you moles or it asks for moles, then you're going to simply do a single step. So if I give you grams and I ask for moles, it's a single step from mass to the mole or from the mole to the mass. Likewise, if it was molecules, I would follow the same logic. If I had molecules and wanted to go to the mole, it's one step, or from the mole to the molecule is a single step. So if the problem gives or asks for moles, one step only. However, if your problem does not give you moles and it doesn't ask for moles, then you're going to have to do 2 steps. The first step, you're going to convert to the mole, and the second step, you're going to convert away from the mole. So I'm going to convert from particles to the mole, and then from moles to grams. That's 2 steps. So that's how you're going to be able to tell the difference. So let's work through some examples. All right, so since we can't go, this is just a repeat of some of the information I gave you in the first slide. We convert to the moles. We convert our starting unit to the mole, and then we convert our moles to the final unit. If you need a review, if you're like a little bit rusty and you want to go back, these 2 are video links to what we did weeks 2 and week 3. So you can go back and watch those videos if you need to. Okay, so we're going to be using molar mass because all of our problems are either going to give us mass or they are going to ask us for mass. So if you're looking for the mass of an element, it's just simply going to be the element's mass from the periodic table. If you have a compound, you're going to find the mass of the compound by adding all the elements' mass from the periodic table. Here's another review for you. This is a little video if you want to review that as well. So we're going to continue to work with this triangle, and we're going to move from grams to moles and moles to particles. Or we will go from particles to moles and moles to grams. So follow along. Our first problem, okay? How many atoms are in 60 grams of carbon? When I look at my periodic table, I find that 1 mole of carbon weighs 12 grams. I put 12 grams of carbon in the bottom so that it will cancel the grams of carbon on top. 12 grams of carbon is equal to 1 mole. So there's my first step. I have gone from the grams to the mole. So that is my first step. But I don't want moles, I want atoms. So I know that 1 mole is equal to 6.02 times 10 to the 23rd particles. So to go from the moles to the particles or atoms, I know that it's 6.02 times 10 to the 23rd. 1 mole of carbon goes on bottom, and the 6.02 times 10 to the 23rd goes on top. Now moles of carbon cancel moles of carbon, and the only unit left are particles, or because carbon is an element, those would be atoms. When I put this into my computer, parentheses, or my calculator, open parentheses, 60.00 times 6.02, second function EE23, close parentheses, divided by parentheses 12.0. And then you should get an answer of 3 times 10 to the 24th. Notice that all of my units canceled except the atoms of carbon. So pause the video if you need to get this example down. Example number 2, very similar. How many atoms are in 450 grams of uranium? Again, I am going to do a two-step problem because I am given grams and I am asked for atoms. That is a two-step problem. I will go from grams to the mole and from moles to atoms. So I start with what's given, 450 grams of uranium, and I need to cancel grams. I look to my periodic table and I find that uranium, 1 mole of uranium weighs 238.03 grams. The grams go on bottom to cancel the grams of uranium here, and that is equal to 1 mole of uranium on top. That is my first step. I've gone from grams to moles. But I need to go my second step, which takes me from moles to the atoms. I know that 1 mole of uranium contains 6.02 times 10 to the 23rd atoms. 1 mole goes on bottom and cancels the unit, and the 6.02 times 10 to the 23rd atoms go on top. Every unit has canceled except the atoms, so now I do the calculation. Open parentheses, 450 times 6.02, second function EE23, close parentheses, divided by, open parentheses, 238.03, close parentheses, equals, you should get 1.14 times 10 to the 24th atoms of uranium. I know some of you are thinking you don't need the parentheses on bottom, and sometimes that is true and sometimes it isn't true. So to save yourself the trouble of trying to think about, do I need them or do I don't, then go ahead and use them all the time. All right, example number 3. How many molecules are in 23.8 grams of water? Okay, same concept. I start with my 23.8 grams of water. I have to look up how much water weighs. I have 2 hydrogens and a single oxygen. When I consult the periodic table and add the mass of 2 hydrogens plus 1 oxygen, it equals 18.02 grams. 1 mole of water equals 18.02 grams. That's how much it weighs. Grams go to the bottom so that it cancels, and that equals my mole. There's my first step. Step number 2 is to take those moles and convert them to molecules. This time I'm looking at molecules because water's a compound. Compounds are always made of molecules. Elements are always made of atoms. I do my math, parentheses 23.8 times 6.02 EE23, close parentheses, divided by, open parentheses, 18.02, close parentheses, equals, you should get 7.95 times 10 to the 23rd molecules of water. Notice again, all but the final units cancel. Moving along, you may pause your video as often and rewind as often as you need. Moving on to the next set of examples. Particles to mass, still a two-step process, but now I'm going to start with my particles. Then I convert to the mole, and then I'm going to convert to grams. The concept is the same, but it's structured just a little differently. You can always consult your page and look at your conversion factors if it helps you, but I'm going to begin with particles and convert to the mole, and then I'm going to go from the mole and convert to the grams. The parentheses in the denominator will be very important for these problems. So, my first example here, which is example 4 on your paper, how many grams are in 3.13 times 10 to the 24th atoms of magnesium? So I still begin with what I was given, 3.13 times 10 to the 24th atoms of magnesium. Notice that it's an element and so my units are atoms. I need to cancel atoms. So if I look at my triangle to go from atoms to moles, I'm going to use 6.02 times 10 to the 23rd. So I'm going to go from atoms to the mole as my first step. So 6.02 times 10 to the 23rd atoms of magnesium in 1 mole. The atoms of magnesium go to the bottom so that the atom unit cancels. The moles of magnesium go to the top because that's what I'm looking for. Now I've canceled atoms, but I need to get to the grams. So now I am in the center of my mole triangle, and I'm going to go from moles to grams, and I'm going to need my molar mass. So I look up magnesium on the periodic table, and I find out that 1 mole of magnesium weighs 24.31 grams. Moles of magnesium on top here means I have to put the moles of magnesium in the bottom to cancel them out. 1 mole of magnesium weighs 24.31 grams of magnesium. All my units have canceled except for the grams of magnesium, which is what I was looking for in my problem. So now I do the math. Grab your calculator, open a set of parentheses. Open a set of parentheses, 3.13 second function EE 24 times 24.31, close your parentheses, divided by, this set of parentheses is essential. Open a set of parentheses on the bottom. Then 6.02 times 10, or second function EE 23, close the parentheses, now hit equals. You should get 126.40 grams of magnesium. If you get 1.26 times 10 to the 47th, or 45th, or 49th, then you did not use your parentheses in the denominator correctly. Try it one more time. Rewind the video and try it again. Last example from your notes page. How many grams are in 2.01 times 10 to the 24th molecules of nitrogen? Notice that this is molecules this time because it's N2. Remember when we have atoms bonded together, that's a molecule. And because it's Brinkelhoff, nitrogen is N2. Again, I start with my given value, 2.01 times 10 to the 24th molecules. I'm going to use my mole triangle, and I'm going to go from molecules to the mole. Because I need to cancel molecules, they must go to the bottom. 6.02 times 10 to the 23rd molecules are always in 1 mole. Molecules of nitrogen have canceled, and now I have moles of nitrogen. That's my first step. The second step is to convert from moles to grams of nitrogen. For every 1 mole of nitrogen, moles go to the bottom so that they cancel. That weighs 28.02. I had to look on my periodic table for the mass of nitrogen, 14.01, but there's a 2, there's 2 of them, so it's 28.02. All the units cancel but grams. Open parentheses, 2.01, second function EE24 times 28. Close your parentheses. Open a new set for the bottom, so divided by new parentheses, 6.02, second function EE23, close parentheses equals. You should get 93.56. So those are 5 examples that go with your note page. There are some additional helpful hints on your note page. Be sure you read through all of those. Have that note page out as you go through this week's practice problems. Don't forget, you can email me anytime with questions, and I have a conference hour from 10 to 11 every day. See ya. Bye.